Welcome to the AI Research Roundup. I'm Alex. Alright, today we're looking at a paper from the Hugging Face Trending List, published on July 30th, 2025, so just 2 days ago. This paper takes a close look at spoken dialogue models. These are the AI systems that generate voice responses directly to your spoken questions. And it finds that when it comes to understanding semantic ambiguity in Chinese, so when a word or phrase has multiple meanings, current models achieve a shockingly low accuracy of just 3.97%. The paper is titled C3, a bilingual benchmark for spoken dialogue models, exploring challenges in complex conversations. And the findings really highlight some major hurdles that today's voice assistants still need to overcome. The authors argue that while text-based LLMs have lots of good benchmarks, these spoken dialogue models are lagging far behind in evaluation, especially for the tricky parts of real human speech. Also, the authors shared their implementation on GitHub, and it's quite complete. You'll find the evaluation scripts to run the C3 benchmark on your own models, tools to process the results, and even the specific prompts they used for their automatic evaluation. Everything you need to get started is there. So, to really dig into these tricky parts of speech, the authors provide some great examples. This figure breaks down the 5 key challenges they built their benchmark around. First is phonological ambiguity, which is just a fancy way of saying the sound can be confusing. For instance, "you're going to the party" can be a statement or a question based only on intonation. Then there's semantic ambiguity, where words themselves have multiple meanings. They also test context dependency through challenges like omission, where we leave words out, coreference, which is linking pronouns to what they refer to, and multi-turn interaction, which tests memory across a longer conversation. Building on that, this next figure visually breaks down what the authors mean by phonological ambiguity. It's basically a Venn diagram. On one side, you have heterographs. These are words that sound the same but have different spellings, like night and night. On the other side are heteronyms, which are spelled the same but pronounced differently, like the verb to lead versus the meta lead. The diagram also points out tone-only differences, a huge source of confusion in languages like Chinese. It's this kind of subtle sound-based complexity that makes spoken dialogue so much harder than text. So, to put these challenges to the test, the researchers built their benchmark dataset, called C3. This table breaks down its contents. It's split into Chinese and English and divided into 2 main parts. The first part, CAM data, focuses on ambiguity, with specific test cases for phonological and semantic issues. The second part, CCON data, handles context dependency, testing things like omission and coreference. You can see they created a lot more semantic ambiguity examples for Chinese, and a huge number of coreference examples for English, really targeting specific weak points in each language. Moving to the results, this table lays out the accuracy scores for several popular spoken dialogue models on that C3 benchmark. The columns show different models, like GPT-4o Audio Previous and Huwen 2.5 Omni, with scores for both Chinese and English. And the results are, well, quite revealing. Across the board, models performed much better in English. For instance, on the ambiguity tests, called CAM data, the overall accuracy was only 12.21% in Chinese versus 27.91% in English. GPT-4o Audio Previous was the clear winner for English, while Huwen 2.5 Omni did best in Chinese, especially in multi-turn conversations. This data really underscores the current language-specific limitations. This table then digs deeper into 2 of those context-dependent challenges, omission and coreference. For each one, the researchers tested 2 separate abilities. First, just detecting that a word was missing, or a pronoun needed a reference, and second, actually completing the missing word, or resolving that reference. And a clear pattern emerges. Models are much better at detection than they are at completion. For instance, with omission in Chinese, the overall detection accuracy is over 38%, but the accuracy for actually completing the thought drops to under 4%. Now, with all these results being generated by other LLMs like GPT-4o acting as judges, you might be wondering how reliable that process is. Well, the authors checked exactly that. This table shows the correlation coefficients, which are basically scores that measure how closely the AI judges' ratings match those of human evaluators. A score of 1 would be a perfect match. As you can see, using measures like Pearson and Spearman, all the scores for both Chinese and English are super high, above 0.87. This strong agreement validates their entire evaluation method. So, in the end, this work really highlights the major hurdles that spoken dialogue models still face. They struggle far more with ambiguity than with context, and there's a significant performance gap between English and Chinese. That's it for this episode.